have here. First ones were just like looking at the graph, making sure they're functions, finding domain and range. Remember, domain and range we use forever. So if you even put this in your calculator or you take a look at where your x values are, you will see there's no errors. There's nothing that stops you from using any x value. So therefore, all real numbers. On the range, find how high up the y's go. They go from negative infinity to 1. Make sure you print it that way. Don't give me from 1 to negative infinity. Okay, we make these a little, I found if I made these a little darker, it helped. Okay, so now, we talked about the f of 0. This is f at x, at the x of 0. So when x is 0, what is the y? 1. That's all it's asking, the value of this function when f is 0. F of 0, f of x. Okay, this guy, a cubing function. It has all real numbers for both. When f is at 0, x is at 0, what is your y? 2. Good? Just a little thing to get you started. Now, another function. Where do you think that, what kind of function do you think that came from? Think back. We did one like this. It was, okay, a piecewise. This is piecewise. How about this one? It was a plus and a minus, but we only did the one side of it. So it was a radical with a quadratic underneath here. And it had a minus something x squared. So 4 minus x squared under here, or probably 16 minus x squared. It had a radical with a quadratic under it, remember? So radical says no negatives. Quadratic says find me the factor, find me the roots. So this had a radical with a quadratic. The domain goes from here to here, -4 to +4. The range goes from here to here, 0 to 4. When x is at 0, y is at 4. F at x. That's what your 0 is. This guy is your piecewise. This is absolutely your piecewise. It had one function that went this way, a line. It had one line that went this way. Here is your point of overlap. But one is open, one is closed. So you're still a function. So technically, all real numbers. If we squish them together, all real numbers. And your range says it's good up like this, and it intersects with this guy, but it never goes lower than a -3. And where is your value when f is at 0? -3. Make sense? Yes.
So you wouldn't say as a range for that it's -3
So if you did this, here's your number line. -3 to infinity, and this is a very good point. And oh, my number line is gone. So is my graph. -3 to infinity, and then here's 2 to infinity. See the overlap?
Even though you're taking this 2, or taking this.
That only applies to the x's, not the y's. But if it was our x domain, then we could only use this one if it was like a radical or domain restriction. But because it is our y values, we can use from -3 on up. Good point. This one, you graph, get a function. Anybody's pencil? Okay. You get a function, guys, come on. That goes in both directions. Do you see its symmetry? Symmetry to what axis? What, the y-axis. So is this function even or odd? Even. If I replace this, I would come out with the same, with a, well, a different y, but I would still come out with a y that would give me this. Increasing, oh, you only have to increasing, decreasing. This guy, even though this comes out here, is starting here and decreasing. This is your decreasing one. This one over here starts here and goes like this. That's your increasing. you're looking at your y values. So you're increasing from 0 to infinity. You're decreasing from negative infinity to 0. That's actually your turning point. You stop and you switch directions. Remember, you're increasing and decreasing. You're looking at your y values, increasing or decreasing. But what you're charting is your x interval. Where is this increasing and decreasing over? This one has a domain restriction. X has to be greater than negative 3, greater than or equal to, and there it is. Where's your point? You could do your zeros here, do your absolute minimum. This is absolutely the most minimum point on your graph. That'll help you do your increasing, decreasing. So technically, we're decreasing right here from negative 2. We're from negative 3 to negative 2. This is your point that it hits here. So from negative 3 to negative 2, you're decreasing, and then you're increasing the rest of the way. You were decreasing for just a short little time. And you might have to find your zeros, or look in your table for that. That would have been in your table as well. Or if you did your domain restriction, tells you where to start your domain at negative 3. So you kind of see them tying together between domains, restrictions, when you put them in the graph, when you look at your table. They're kind of fitting together. I like this part when we graph these because I think it actually starts to tie them in for you. At this point, you know how to find your zeros, you know how to find your maximums, you know how to look at your table to see where it's passing through. You need to see if there's errors out there. It does start to make a little bit more sense. I hope it does. This one, 33, was a little different. It had a decreasing, a constant, and an increasing. I'm decreasing to here, so decreasing from negative infinity to negative 1, and you can find that point right there. Then you have a constant from negative 1 to positive 1. It is neither decreasing nor increasing. It stays constant. The value of y is not changing. And then increasing from 1 to infinity. Again, in number 35, it's a parabola. It's opening up. Find your vertex point. This is your absolute minimum point on this. This is your vertex point or your turning point. So you're decreasing from negative infinity to 3, and you're increasing from 3 to infinity. Yeah? Good? Okay. Now, sketch and describe. Let's do a few more things here. We graphed this. We notice it's a cubing function. Did you guys all do the intercepts as well? Did you work out your intercepts? It didn't exactly say it on your directions, but I did want you to do them all. Did you follow your sheet and do them all?
Do you have to do that? Because can't you just find it on the calculator?
Nope, because you got to find those algebraically. You can check them on the calculator. But increasing, decreasing, we can look to see where the points are, look where everything's going. The intercepts, we have to solve those algebraically. And the odd evens, even though we can see symmetry, we still have to solve those algebraically and prove. But your calculator is a great tool to verify that this was in fact right. Now, when you graph this, your domain is what? All real numbers. Good. What's your range? All real numbers. Okay? We found we had no absolute max because it kept on going forever. We had no absolute min because it kept on going forever. But we do have a relative max and a relative min. That's relative to that part of the graph. And when you do that on your calculator, you have to make sure that you pinpoint that part exactly. Now, Friday, a couple of you, I don't know if it was this class or my other class, were calling me over to say I didn't get your point. Because what happens is, if you don't grab that section, it's going to give you the min or the max of whatever section you tell it to look for. So if you pull it and it's down here somewhere, and you're just checking this piece in here, that's going to come up with the maximum just for that piece. So you really need to make sure that your little cursor guide goes to both sides of it. And when you see those arrows, you should be able to follow those arrows through and say, yep, I'm going to hit my maximum.
Oh, that's
Yep.
so
Yeah, that's why you get those two little arrows right up here, and they look like this, Vanessa. And so now it's searching all the way down this column, and it says, give me your maximum point. So move your cursor to the left of it, to the right of it, hit enter for guess.
Okay,
And
so
it
that keeps
pinpoints.
going to like the left, but then all the way to the right, so like a different.
So then it's going to find a different point.
Yeah.
Yeah, because now if you caught any of this other piece of this graph, it's going to take that point as its maximum. Yeah, so you have to isolate these. Do the same thing for the minimum. Now, once you do this, ladies, especially if you weren't here, I'd be really paying attention to this. Well, I just erased it all, so I guess we're not paying too much attention to it now. But I was trying to erase my marks. You want to be careful when you do this that you record your minimum and your maximum points out there so that you can do your increasing and decreasing to that. Now, algebraically, to find your intercepts, if you set this equal to 0, and I don't know if all theirs is going to work, you should be able to factor out an x. And now you should see if you should be able to, I took my graph away, if it's going to come out to be a rational point or an irrational point. Did anybody find the roots on this? Did you do your intercepts or you didn't bother on this part?
It's -3.312.
Okay, so it is a definite irrational number, right? So we'd have to use the quadratic equation to do this. Now, to check it, just exactly what Jana did. She went to her zeros and she checked it in her calculator and make sure they come out okay. 39, I just did the basic increasing, decreasing. What's the domain for this guy? What's my domain? How do I find my domain? Aaron, how do I find my domain? Just looking at this equation, without looking at the graph. You have the equation in front of you. What part gives you problems? The square root. So what do I make this be underneath the square root sign? Can be negative, can be positive, can be 0. What can it not be at all? Under a radical sign. Can't be negative. Can it be 0? Can you take the square root of 0? 0. So it can't be negative. So I make this greater than or equal to 0. Here's my domain. 0 to infinity. Here's your domain. Could I find it right here at this point right here if I looked at my table and I graphed it? That would be there. There's the point 0, 0. You would look at your table and you would say, I have no negatives here. It does tie in, guys, is what I'm trying to drive the point home here. The graph, with the rules, with your table, with everything else we do, ties together. It has a little bit of a decrease, so we've got an absolute minimum. That's absolutely the minimum point of your graph. There's no max because it keeps on going. So do an absolute minimum rounded to 3 decimal places. So you're decreasing from your 0 to this x value, and you're increasing from here to infinity. Okay? And this last one was a nice little parabola that also was factorable this time. So you could find all your pieces, your absolute minimum. What's the domain for this? All real numbers. What's the range? -9. Good. Once you find this point, you can find the range of it. Until you find that point, you're not going to be able to find its range. So whether you look at a vertex point, look for the turning point, do a minimum. Minimum is probably your best bet because it's not always a whole number as we've been seeing. So you're decreasing to this point, to your x, you're increasing. Questions on these? No? Okay. Now, okay. Graph this in your calculator. And have your chart handy that explains all the pieces that we need. And it looks like an M, right? An upside down W. And it looks like this, right? Okay. Now, let's walk through your chart. What's your domain? I want it absolutely quiet. What's the domain? Good. Now, the range is a little bit hard for me to see right from my graph, right? Because I need to know what is my highest point. Do I have a relative maximum or an absolute maximum? Absolute. I have two absolute maximums, right? So we're going to put this in your calculator, and we're going to isolate this. So I'm going to pull out my calculator, and you're going to do a max in this as well. And go 3 decimal places.